So following on from the previous video, we were trying to sum up all the terms of this geometric series from the first term all the way to infinity, from the first term all the way to infinity. But rather than looking at this one specific case where a equals a half, we would look at the general case. So our aim here is to sum up from the first term all the way to infinity, from the first term all the way to infinity. But the way we're going to do that is we're going to sum it up from the first term to some arbitrary term. So sum it up from the first term to some arbitrary term, and then later take the limit as capital N tends to infinity. So that's our aim. Okay, so we're going to sum it up from the first term to some arbitrary term. So us summing up from the first term to some arbitrary term, from the first term to some arbitrary term. So if you were to continue this would be, the next term would be this, capital N, and then the next one would be A, R, capital N plus 1, and so on. There are more terms over here, but we don't care. We are just summing up from here to some arbitrary term. So we're just looking at from the first term to some arbitrary term. So we got to this stage here where this thing can be written as this. So from here to here is nothing more than a notation. So this here is another way of writing this. So this is exactly the same as this. So we got to this stage in the previous video. So from here, times both sides by your common ratio. So this side times this by r, by the common ratio, by this r here, and then on this side times a whole lot by r. So now this times this would then give you this. This times this would then give you this. This times this would then give you this, and so on. And then this times this, the very last one, would be now it's r to the power of n, as opposed to n minus 1. So from here, times both sides by r. Okay, so times both sides by r. That would then give us this. Okay, so now from here, if you look at this matches up with this matches up with this, and so on. So I'm gonna looking at this here. Hang on, looking at this here. I'm gonna just shift this across slightly. So that this matches up with this. So I'm just going to shift this block here slightly across to the right. So I'm just going to shift it across slightly to the right. So now you can see that this thing here matches up, this thing here matches up, and so on. So hang on. Earlier we were here. We would times both sides by r. So that would then give us this thing here. So now the trick is to get this, take away this. So when you get the first, take away the second, on the left hand side you will have Sn, take away this, and then on this side, if you get this, take away this, that would then give you this. Hang on. So these two would cancel out, these two would cancel out, and so on. And by the way, the term prior to this one would be, hang on, the term prior to this one would be, the term prior to this one would be A, R, capital N minus 1. So the term prior to this would be A, R, capital N minus 1. So notice that this would cancel out with this term here. So the point here is that if you get this, take away this, you're going to get this, because these would cancel out, these would cancel out, all the middle ones would cancel out, this would cancel out with the previous one. All that's left here is this thing here, which is this, and then you've got your A here, which is this. So don't forget you've got nothing here. Take away this thing here will give you minus. Well, if you get this, take away this, it will then give you this. So now factorize out Sn. So that will then, this thing here can be rewritten as this. Factor out the A, that will then give you this. Now you're trying to seek Sn. So divide both sides by 1 minus r. That will then give you this. Okay, that will then give you this. So if you sum up from from the first term to some arbitrary term, it will then give you this. So now take the limit as capital N tends to infinity. So if you look at this here, if the common ratio is less than 1, so if the common ratio is less than 1, let's say a half, if the common ratio is less than 1, then when you take when n tends to infinity, well, if you get a half times a half times a half times a half, it's just going to get smaller and smaller and smaller. If you get a number, let's say 1 over 9 times 1 over 9 times 1 over 9. The point is, if this common ratio is less than 1, and then as n tends to infinity, this thing here is going to head towards 0. This thing here is going to head towards 0. So 1 take away 0. This thing here will be 1. So what's on the top is really a, just a. What's on the top is, well, this thing here is going to be 1. So a times 1 would be this. And then, but the point here is that your whole series, hang on, let's go back one step. So we got to this stage here. As you take the limit, as n tends to infinity, remember, we are summing up from the first term all the way to our aim here is to sum up from the first term all the way to infinity. That's our aim. But we've been doing it from the first term to n. So now as n, the minute you take the limit as n tends to infinity, this becomes the true series. So remember this notation here. Remember, S on its own is really you summing up from the first term all the way to infinity. Sn is you summing up from the first term to some arbitrary term. But then the minute you take the limit as n tends to infinity, then you can say it's no longer Sn. It is now the whole series. It's now from the first term all the way to infinity. The point is that from here, if you take the limit as n tends to infinity, this then becomes this. So when you take the limit as n tends to infinity, this is going to be 0 here, making this to be 1. 1 times a would be a. Basically, the whole series would be given by this. And something to bear in mind, when you look at this, it breaks down if your common ratio equals 1. Just bear that in mind. If you have a series where the common ratio is less than 1, then it's going to converge. Well, the whole series will be given this. So back to our series here. This was what we were trying to seek. So here a is, remember, a here is 1. A here is 1, and our common ratio is a half. So if you look at the formula, hang on, this here is our formula here. This here is our formula. Notice that r here is less than 1. It's less than 1. So basically, we're going to put this into the r here, and then a is actually 1. Don't forget, this is 1 times this thing here. So put the 1 into a. That will then give us this, and then this whole thing here equals 2. So if you sum up everything from the first term all the way to infinity, it will come to 2. Okay.